Right now, there's a structure so vast, so impossibly enormous, that it challenges the very laws of cosmic uniformity. The Hercules-Corona Borealis Great Wall stretches across 10 billion light-years of space, a structure so immense that light itself needs almost the entire age of the universe to cross it. Tonight, we'll drift through this cosmic monument, this silent continent of galaxies, and ask the question that keeps cosmologists awake at night. How can something this big even exist in a universe that shouldn't allow it? If you enjoy these cosmic journeys, please like and subscribe. Let's begin. When astronomers first began charting the universe, they imagined galaxies scattered randomly like stars on a canvas. But as our instruments improved, patterns began to emerge, filaments, walls, and voids forming a cosmic web. What appeared chaotic was, in truth, a vast architecture, stitched together by invisible gravity and time. At first, the early sky surveys looked like snow on dark glass, countless dots, each a galaxy sprinkled through blackness. They seemed random, meaningless, disconnected. But when scientists mapped more of them, the randomness dissolved. The dots formed clusters, the clusters formed chains, and the chains curved into filaments stretching across billions of light years. Between them yawned vast empty spaces, cosmic voids so enormous that our entire Milky Way could vanish inside one and drift for eternity without touching another galaxy. The universe, it turned out, was not chaos at all. It was order on a scale so immense it masqueraded as disorder. The pattern we discovered, this cosmic web, became one of the most profound revelations in modern science. It showed that gravity, over billions of years, could sculpt the universe into something almost organic. Where the pull of mass was strongest, galaxies bloomed like flowers on invisible stems of dark matter. Where the pull weakened, space thinned into great hollows of silence. To build this map, scientists turned telescopes into time machines. Each galaxy they observed sat billions of light-years away, its light carrying the story of a younger universe. Computers transformed that data into a three-dimensional atlas of creation. When the map came together, what it revealed was breathtaking. A luminous skeleton of the cosmos, every glowing thread a river of galaxies flowing through the dark. Imagine drifting above it, seeing not empty space, but filaments of light glowing softly like veins in a living being. You would pass through clusters so dense they shine brighter than entire regions of the sky, then glide into vast black oceans where not a single star exists. This is the universe's true face, delicate, structured, and endlessly expanding. The cosmic web redefined what everything means. It showed that our Milky Way is not a solitary island, but one bead of light in a grand chain extending across infinity. We are part of the Laniakea supercluster, immeasurable heaven, a region 500 million light-years wide that flows through the larger web like a single current in a cosmic tide. And yet, even this colossal structure is only a fraction of the total. Beyond our maps lie uncharted threads, invisible in the dark, stretching farther than light has had time to travel. Somewhere within those distant filaments may lie other walls, other webs, other homes for life, unreachable but real. When we look at the map of the infinite, we're not just seeing where galaxies are. We're seeing the universe's handwriting, the geometry of existence itself written in light across the endless dark. In 2013, astronomers studying gamma-ray bursts, powerful flashes from the depths of distant stars, noticed something odd. Many of these bursts clustered together in one region of the sky, forming a pattern too large to ignore. That cluster would reveal itself as the largest known structure in the observable universe, the Hercules-Corona Borealis Great Wall. It began, as many cosmic revelations do, with a small anomaly. Gamma-ray bursts are some of the most violent events in existence, explosions so bright they can outshine entire galaxies for a few seconds. They're the universe's death throes, the final flashes of massive stars collapsing into black holes. Astronomers use them as markers because they can be seen across billions of light years, beacons scattered through space and time. Normally, these bursts appear randomly across the sky, each from a different galaxy, each from a different era. But when researchers plotted hundreds of them on a celestial map, something broke the pattern. Instead of randomness, they saw clustering, a vast, coherent region of bursts grouped together, stretching across a tenth of the observable sky. The scale was beyond comprehension. Even before exact distances were calculated, scientists knew something extraordinary was hiding there. When the light from those gamma-ray bursts was measured and analyzed, it all pointed to the same rough distance from Earth, around 10 billion light-years away. That's when the impossible picture came into focus. These weren't random explosions. They were scattered across a single, interconnected structure spanning 10 billion light-years in width. To put that into perspective, the Hercules-Corona Borealis Great Wall is nearly 1/10 the diameter of the observable universe itself. It's so large that light, traveling at 670 million miles per hour, would take almost the entire age of the universe to cross from one side to the other. When the discovery was announced, it sent shockwaves through cosmology. According to our best models, structures this enormous should not exist. The laws of cosmic uniformity, the idea that matter is evenly distributed on the largest scales, were suddenly in question. Skeptics thought it was a statistical illusion, a coincidence born of limited data. But as more gamma-ray bursts were detected in the same region, the evidence strengthened. It wasn't random. It wasn't coincidence. Something immense was really there. It wasn't a single object, but a colossal assembly of galaxy clusters, filaments, and voids, a gravitational continent floating in the dark sea of the cosmos. The discovery forced scientists to re-examine the fabric of the universe itself. If this structure exists, then our current understanding of cosmic evolution, how matter clumped together after the Big Bang, might be incomplete. Maybe gravity, dark matter, or even the shape of space-time behaves differently on scales this vast. Or perhaps we've stumbled upon the limits of what uniform truly means. Every so often, astronomy delivers a revelation that bends our concept of reality. The Hercules-Corona Borealis Great Wall isn't just a collection of galaxies, it's a boundary of understanding, a reminder that even with all our instruments and equations, the universe still hides mysteries so vast they seem to break the sky itself. To grasp its size, imagine lining up 100,000 Milky Way galaxies, edge to edge. Even that chain would fall short. This structure spans over 10 billion light-years, a distance so vast that it takes nearly 3/4 of the universe's lifetime for light to traverse it. The numbers sound abstract, but they represent something real, a shape so immense it defies the human imagination. Light, the fastest thing that exists, has been moving since long before our solar system formed, and it still wouldn't have crossed the full length of the Hercules-Corona Borealis Great Wall. When we speak of such distances, we are no longer measuring space. We are measuring time itself, the age of everything condensed into a single span of darkness and light. Astronomers didn't find this structure by seeing it directly. They discovered it through the faint signatures of gamma-ray bursts, the dying breaths of ancient stars. These bursts act like cosmic flares, marking where galaxies once thrived. When researchers plotted their positions and distances, they noticed a strange pattern. The bursts formed a continuous region, all roughly 10 billion light-years away. They weren't scattered at random. They were connected, part of one colossal formation that spanned a tenth of the observable universe. But calling it a wall can be misleading. It isn't a solid sheet of matter. It's a gravitational arrangement, a region of slightly higher density where galaxies and galaxy clusters have gathered along immense filaments of dark matter. Picture a web of starlight stretched across an invisible framework, each strand glowing faintly in the deep. Between those strands lie vast cosmic voids, each one larger than any galaxy could ever cross. To imagine its true scale, shrink the Milky Way to the size of a grain of sand. The Hercules Wall would stretch farther than a continent. Every speck in that line would be a galaxy, billions of stars, planets, and worlds orbiting through time. It is not simply big, it is beyond what current cosmology predicts can exist. Our best models say that cosmic structures should stop forming beyond about 1 billion light-years in size. Gravity shouldn't be able to knit matter together over distances much larger than that. Yet here stands a wall 8 times greater. Either our understanding of structure formation is incomplete, or the universe itself contains patterns more ancient and complex than we imagined. Some scientists think the wall traces back to the universe's earliest ripples, the primordial waves imprinted on space just after the Big Bang. Over billions of years, those ripples stretched, thickened, and froze into the grand architecture we see today. Others suggest we may be glimpsing an illusion. Overlapping filaments that only appear connected because of the way light reaches us through expanding space. Whatever its nature, the Hercules-Corona Borealis Great Wall reminds us how fragile our sense of scale truly is. We are mapping distances so vast that even light, the universe's fastest messenger, still hasn't finished the journey across them. And yet somehow, from a tiny planet orbiting an average star, we can measure the impossible and find our place within it. The universe, according to our best theories, should look roughly the same everywhere. No structures larger than 1.2 billion light-years should exist. Yet this wall defies that limit 8 times over. It shouldn't exist, and yet it does. Calmly glowing in the darkness, a fingerprint of something deeper than our models can explain. Cosmology is built on a principle called the cosmological principle. The idea that on a large enough scale, the universe is homogeneous and isotropic. In other words, it has no center, no edge, and no special direction. Matter should be evenly distributed, smooth as fog, identical no matter where you look. But the Hercules-Corona Borealis Great Wall laughs at that symmetry. It is not smooth, it is not even. It is a jagged scar on the face of the universe, proof that somewhere the laws we've trusted might begin to bend. If this structure truly spans 10 billion light-years, it violates what scientists call the end of greatness. That's the scale at which cosmic structures should stop forming. Beyond it, the pull of gravity weakens and random distribution takes over. But the Great Wall ignores that boundary entirely. It suggests that gravity, or something behaving like it, can coordinate matter across distances that our equations can't justify. For decades, cosmologists have relied on simulations to model how galaxies form. Starting from the nearly uniform soup after the Big Bang, these models show small clumps of matter growing under gravity, merging into clusters, filaments, and superclusters. Yet even the most advanced simulations fail to produce anything as enormous as this wall. The mathematics simply breaks. Either our assumptions are incomplete, or something unseen is shaping the universe on unimaginable scales. Some scientists propose that dark matter may not be evenly distributed after all. Perhaps it clumps differently than we thought, forming deeper gravitational wells that pull galaxies into vast continental arrangements. Others suspect the influence of dark energy, the mysterious force accelerating cosmic expansion. Maybe the Hercules Wall marks a region where that expansion behaves differently, where space-time stretches unevenly, creating gravitational tides that gathered galaxies into this colossal shape. And then there's the possibility that our cosmic horizon is deceiving us. What we see as one continuous structure could be a series of separate regions aligned by chance, made to look connected by the way light bends through expanding space. Yet, the statistical odds of that happening are microscopic. The simplest explanation remains the strangest. The wall is real, and it simply shouldn't be. If true, this structure forces us to reconsider one of science's most sacred beliefs, that the universe is the same everywhere, governed by the same rules. The Hercules-Corona Borealis Great Wall may be whispering that the cosmos is more complex, more asymmetric, perhaps more alive than we ever imagined. It stands as a serene rebellion against our understanding, a silent protest written in galaxies and light. A reminder that even in a universe built on laws, there are still miracles vast enough to break them. When you zoom out far enough, galaxies form filaments and clusters. glowing threads woven through invisible dark matter. Between them lie cosmic voids, immense, empty spaces spanning hundreds of millions of light years. Together, these threads form the skeleton of the universe, and at the intersection of those threads, we find the Great Walls. It's a sight no human eye will ever truly see, yet one that defines everything. The cosmic web is the largest pattern in existence, a map of how gravity and time sculpted matter into shape. Each filament is a bridge of galaxies, stretching across billions of light years. From afar, the universe looks like a vast neural network, luminous veins pulsing faintly in a sea of darkness. It's a web of unimaginable delicacy, and yet it holds everything together. The filaments themselves are made not just of galaxies, but of invisible scaffolding, dark matter, the unseen substance that outweighs ordinary matter 5-1. We cannot see it, but its gravity reveals its presence. It threads the cosmos like spider silk, pulling ordinary matter along its lines. Where the strands intersect, gravity intensifies, and galaxies gather into clusters. These junctions are the universe's great cities, places like the Sloan Great Wall, the Shapley Supercluster, and the immense Hercules-Corona Borealis Great Wall. The voids between them are vast and silent. Some span 500 million light-years across, nearly empty except for the faint whisper of hydrogen gas. If you could drift through one, you would not encounter a single star for eons. The emptiness would feel infinite, the quiet hum of a cosmos at rest. Yet, that emptiness is what defines the structure. Just as silence shapes music, these voids give form to the web's luminous threads. When astronomers mapped this structure in 3 dimensions, it reshaped our understanding of the universe. What looked like chaos was, in fact, a hidden order, the architecture of creation itself. The web connects every galaxy to every other through a network of gravity, gas, and motion. The Milky Way, our home, lies along one delicate filament inside a supercluster called Laniakea. Beyond it, the threads stretch outward into infinity, connecting us, faintly but inexorably, to everything else. The formation of this web began soon after the Big Bang. Minute fluctuations in the density of matter expanded under gravity's slow pull, growing into the first filaments. Over billions of years, they thickened, merging into colossal rivers of galaxies. Galaxies drift along its currents, flowing toward denser intersections like leaves caught in cosmic tides. The Hercules-Corona Borealis Great Wall sits at one of those crossings, a colossal node where several filaments converge. It is not a single structure, but a gathering of thousands of galaxy clusters, each one the size of a universe in its own right. It is where the cosmic web's threads knot together, forming a structure so immense that light struggles to describe it. When you picture the night sky, remember this. Every point of light above you is part of that web. Every star, every galaxy, every distant cluster, all connected by invisible lines of gravity. You are not separate from it. You are woven into it. A flicker of consciousness suspended in the cosmic web that binds all things. Before Hercules-Corona Borealis, we thought the Sloan Great Wall was the largest structure in existence. Then came the huge LQG, a quasar cluster spanning 4 billion light-years. Each discovery stretched our sense of scale, until Hercules shattered it completely. The history of cosmology is a story of ever-expanding horizons. Each time we believe we've found the edge of greatness, the universe quietly reveals another layer, larger, older, and more complex than the last. For decades, astronomers have mapped these colossal features, each one redefining what large truly means. The first of these, the CFA-2 Great Wall, discovered in 1989, stunned scientists by stretching 500 million light-years across. At the time, that distance felt almost unthinkable, a curtain of galaxies longer than any known structure. But the cosmos was only beginning to reveal its architecture. In 2003, the Sloan Great Wall was found, dwarfing its predecessor. It spanned 1.4 billion light-years, 3 times longer than the previous record. The name wall became fitting, not because these were solid boundaries, but because they were sheets of galaxies, like waves frozen in the vast sea of space-time. Galaxies clung to these walls in clusters and filaments, each shining as a single cell in a galactic organism. For a time, the Sloan Great Wall was thought to be the universe's largest coherent structure, until the data deepened and the universe humbled us once again. Enter the huge LQG, the Huge Large Quasar Group, discovered in 2013. It was not composed of galaxies alone, but of quasars, the blazing hearts of young galaxies powered by supermassive black holes. These quasars formed a chain 4 billion light-years long, spanning nearly 1/15 of the observable cosmos. Scientists debated whether it could even exist according to the cosmological principle, the same principle Hercules would later demolish entirely. Yet even this massive formation proved to be only a stepping stone to something greater. When the Hercules-Corona Borealis Great Wall was identified later that same year, it didn't just set a new record, it redefined the possible. At 10 billion light-years across, it surpassed every known limit by an order of magnitude. It wasn't just larger than anything ever seen, it was too large for our current understanding of the universe to explain. Every law of structure formation said such a wall couldn't exist, and yet there it was, stretching across time and space like a scar left over from the universe's early turbulence. These cosmic walls, Sloan, CFA2, the huge LQG, and Hercules-Corona Borealis, are the universe's most breathtaking paradoxes. They are not solid boundaries, but immense gatherings of galaxies, quasars, and dark matter filaments, where gravity's quiet persistence has shaped creation itself. Each wall marks a place where the cosmic web knots together, creating regions of light that span billions of years and contain billions of galaxies. And when we compare them side by side, something extraordinary becomes clear. The universe is not simply vast, it is layered, hierarchical, and infinitely creative. Every largest structure we find becomes a doorway to something grander, a reminder that even our greatest measurements are merely the first whispers of the infinite. The great walls of the cosmos are not just discoveries, they are thresholds. Cosmic monuments showing us that, in the universe's architecture, there is no final scale. There is always something larger waiting to be found. If you could see the universe in dark matter rather than light, you'd witness a ghostly lattice stretching beyond imagination. Dark matter doesn't glow, but its gravity shapes everything. The Hercules wall may be just one ripple in this invisible ocean, a shadow cast by something much greater than light can reveal. For every galaxy you can see, there are 5 times more mass you cannot. The stars, planets, and gas that fill our telescopes make up only a small fraction of what truly exists. The rest, the unseen majority, is dark matter. It neither emits nor absorbs light. To our eyes it's invisible. To our instruments it's silent. Yet, its gravitational pull sculpts the universe on every scale, from the formation of galaxies to the weaving of the cosmic web itself. Imagine stripping away the starlight from the night sky. The universe would not disappear. It would come alive in a different way. You would see an immense framework of shadow, an intricate web of invisible strands connecting clusters of galaxies like dewdrops on a spider's silk. Every filament of the cosmic web, every great wall of galaxies, is strung along this hidden structure. Without dark matter, the universe, as we know it, could never have formed. Scientists first suspected dark matter's existence in the 1930 seconds, when galaxies within clusters moved too quickly to be held together by visible mass alone. Something unseen had to be generating the extra gravity, something massive, pervasive, and invisible. Later, when astronomers measured how galaxies rotate, they found their outer stars moving far too fast. The galaxies should have torn themselves apart, yet they held together as though cradled in an invisible halo of unseen mass. That invisible presence was dark matter. Today, dark matter remains one of science's deepest mysteries. It makes up roughly 27% of the universe, yet we still don't know what it is made of. It could be exotic particles that barely interact with ordinary matter, or something even stranger. Perhaps a hidden property of space-time itself. We can't see it directly, but we can map where it lies by watching how it bends light through gravitational lensing, curving the paths of distant galaxies into arcs and rings. These distortions trace the fingerprints of the invisible, showing us the skeleton of creation. The Hercules-Corona Borealis Great Wall likely owes its very existence to this hidden scaffolding. Its galaxies are strung along massive filaments of dark matter, drawn together by gravity over billions of years. What we call a wall of galaxies is, in truth, the faintest trace of a deeper, unseen structure, a gravitational continent submerged beneath the visible cosmos. Perhaps dark matter is the quiet artist of the universe, shaping, binding, and supporting everything, yet remaining forever unseen. The stars are merely its brushstrokes, revealing just enough for us to guess at the masterpiece beneath. Somewhere, hidden within that ghostly framework, lies the true form of the cosmos, and maybe the reason it exists at all. Each galaxy within this structure is a universe of its own, billions of stars, countless worlds, and perhaps life looking back across the darkness. These galaxies are connected by invisible highways of gas and gravity, flowing like rivers across the cosmic web. It's difficult to imagine such motion on scales this vast. From our tiny vantage point, the night sky looks frozen, the stars fixed, eternal. But across billions of light years, everything moves. Galaxies drift along filaments of dark matter like leaves carried by an unseen current. The Hercules-Corona Borealis Great Wall is not static. It is alive with motion, a slow, endless migration that has been unfolding for 10 billion years. Each filament acts as a gravitational channel, a kind of intergalactic river where matter flows toward denser regions, the great junctions where superclusters form. Over cosmic time, galaxies merge, cluster, and reshape themselves along these paths. Hydrogen gas streams through the filaments, feeding newborn stars. Dark matter threads hold the pattern together, guiding galaxies as they swirl around one another in a graceful billion-year dance. Within each of these galaxies lies an ocean of possibilities. Some harbour spiral arms glittering with blue-white stars. Others are giant ellipticals, ancient and red, filled with the quiet glow of suns that have long stopped burning hydrogen. Every one of them contains hundreds of billions of stars and likely trillions of worlds. Somewhere out there, civilizations may be rising, staring into their own night skies, wondering if the faint glow they see is us looking back. And yet, what connects them all is not light, but gravity. These invisible highways are cosmic arteries, ferrying matter and energy across the skeleton of creation. When astronomers use radio telescopes to detect faint streams of hydrogen, they see bridges of gas stretching for millions of light years between galaxies, literal rivers of time, carrying the raw material for future stars. It's through these cosmic flows that galaxies continue to grow, merging their fates into ever larger structures. If you could watch this process sped up, a billion years passing every second, you would see the Great Wall writhe like a living organism. Filaments pulse as matter flows through them, voids expand like lungs exhaling darkness, and clusters at the intersections flare with new bursts of starlight. The universe would look less like empty space and more like a vast, slow-breathing being. But even at that scale, everything obeys the same simple rule: gravity pulls and time flows. The same law that draws an apple to the ground binds galaxies together across unimaginable distances. From this simplicity, the cosmos has built a masterpiece, a network so intricate that it mirrors the complexity of life itself. Each thread of the Hercules-Corona Borealis Great Wall is a story written in gravity and light, each galaxy a page in that ancient book. Together, they form a single flowing narrative. A river of stars moving endlessly through time, whispering that creation is not still but always becoming. When we see the Hercules-Corona Borealis Great Wall, we aren't seeing it as it is, we're seeing it as it was 10 billion years ago. Back when the universe was young, when the first galaxies had only just begun to shine, the light reaching us tonight began its journey before Earth existed. It's one of the most haunting truths in all of astronomy. Every time we look into the night sky, we are looking into the past. The stars above us are not what they are, but what they were. Light is fast, but not instantaneous. It takes time, sometimes minutes, sometimes eons, to cross the endless distances between worlds. The glow from the Hercules-Corona Borealis Great Wall began its voyage when the cosmos was less than a third of its current age. Back then, the Milky Way was still forming, and our sun was billions of years away from igniting. That means the light now entering our telescopes has travelled through 10 billion years of cosmic history. Through expanding space, through the birth and death of countless stars, through collisions of galaxies and the slow stretching of the universe itself. Every photon we collect from that distant structure is a messenger from an ancient epoch, a fragment of time preserved in its wavelength. The universe is not just vast in space, it is vast in memory. Imagine holding a single beam of that light in your hand. Inside it lies the history of everything it passed. The invisible fog of hydrogen from the early universe, the flare of supernovae, the cold vacuum between galaxies. It is light that has seen creation itself unfold. Yet when it arrives, it does so silently, striking the mirror of a telescope with no fanfare, just a whisper of the past made visible. The Hercules Wall, as we see it, may not even exist in the same form anymore. Over 10 billion years, galaxies collide, merge and change. Entire clusters may have shifted or dissolved. Stars that once burned bright may have faded into cold embers. The structure we admire in our maps is a ghost, the fossilized image of what once was. In a sense, we are archaeologists of light, unearthing relics from the dawn of time. The farther we look into space, the younger the universe appears. This strange inversion, where distance equals time, means that telescopes are not just tools of observation, but instruments of time travel. Each deeper survey pulls us further into the past, closer to the moment of beginning. When we gaze upon the Hercules-Corona Borealis Great Wall, we are witnessing the young universe still finding its form, its matter still settling into the grand design that defines everything today. To look at it is to hold a conversation with the past, a conversation carried on beams of light that began before life had a name, before Earth had an orbit, before there was even a sky to look from. The light that reaches us late is a message from a time when the universe was still learning to shine, and it has been travelling ever since, waiting for someone, somewhere, to notice. Every photon that reaches our telescopes carries a memory, a fragment of ancient starlight whispering from the past. To study the Hercules Wall is to look through a time machine, into an era when galaxies were still forming, when dark matter sculpted the first cosmic structures from chaos. The universe remembers everything, not through words or artifacts, but through light, that most patient of travellers. Each ray carries with it the signature of where it came from. The chemical fingerprints of the stars it left behind, the distortions of the galaxies it passed, the redshift of an expanding universe stretching it thinner and longer as it journeys across time. When astronomers catch these photons, they are collecting history itself, bottled moments from when the cosmos was young. When we observe the Hercules-Corona Borealis Great Wall, we are not just seeing distance, we are seeing time stacked upon time. The light from those galaxies began its voyage 10 billion years ago, when the first heavy elements were only beginning to form inside stars. It passed through the young universe, weaving its way through growing filaments of dark matter, through collapsing clusters of galaxies, and through expanding space itself. Each photon that reaches our instruments is a survivor, a traveller that has crossed almost the entire history of everything. What we see, then, is not the present universe, but its fossil record. The galaxies that form the Hercules Wall today may look nothing like they did when that light left them. Some may have collided or merged. Some may have died, their stars cooling into ash. but their light remains, carrying a perfect snapshot of who they once were. The universe forgets nothing. It simply records its story in wavelengths too vast for the human eye to see. This memory is encoded everywhere, in the cosmic microwave background that still hums with the echo of the Big Bang, in the faint glow of ancient quasars, in the ripples of gravitational waves that stretch and squeeze the very fabric of space. It builds upon it, layer by layer, until time itself becomes a visible texture spread across the night sky. To study the Hercules Wall is to peel back those layers. Astronomers translate the color of ancient light into temperature, composition, and distance. They reconstruct the story of how galaxies grew, how gas collapsed under the pull of gravity, igniting stars that forged new elements, which later became planets and life. In that way, every observation becomes an act of remembrance. We are reading the autobiography of existence, written across billions of years in light and shadow. And here on our tiny world, we become part of that story. The iron in our blood, the calcium in our bones, the gold in our rings, all forged in the furnaces of long-dead stars whose light we still see. The universe remembers not only its stars and walls of galaxies, but also us. Tiny echoes of the same creation, looking back across time to understand where we came from. The Hercules-Corona Borealis Great Wall is not just a monument of galaxies. It is a memory frozen in light, a cosmic photograph of the universe's youth, still developing across the endless dark. Gravity doesn't build quickly. It sculpts over eons, pulling threads of matter together like slow, invisible hands weaving a tapestry of light. The Hercules Wall may be the result of billions of years of gentle attraction, a quiet accumulation of galaxies drawn together by the faintest tug. It's difficult to imagine something so immense forming not through violence, but through patience. Gravity works in silence, with a persistence unmatched by anything else in the universe. It doesn't rush or rage. It simply waits, pulling, gathering, shaping. Over time, what begins as a faint density ripple in the aftermath of the Big Bang grows into something magnificent. Clusters of galaxies, filaments of light, and eventually, the colossal walls that define the structure of the cosmos. In the early universe, matter was nearly uniform, a sea of hydrogen gas, smooth and unbroken. But even perfection trembles. Tiny fluctuations, mere 1 part in 100,000 differences in density, appeared in that young cosmic soup. Gravity noticed. Where there was slightly more matter, it pulled in more still, deepening the well. Slowly, those regions grew heavier, denser, and brighter, while the emptier regions became the vast voids we see today. Over billions of years, this process created the great architecture of the cosmos. The Hercules-Corona Borealis Great Wall is one of its grandest achievements, the result of gravity's endless patience. Imagine the slow fall of galaxies toward one another, each move measured not in years but in epochs. Every motion, every collision, every merger takes hundreds of millions of years, yet gravity never tires. It keeps building, pulling galaxies into clusters, clusters into filaments, and filaments into walls of almost incomprehensible scale. It's tempting to think of gravity as a force that acts only between two objects, between the Earth and the Moon, or between you and the ground. But on the scale of the universe, it becomes something far more poetic. A sculptor of eternity. It molds chaos into structure, randomness into pattern, light into form. Every galaxy's motion, every star's orbit, is part of a choreography written by gravity's hand. In that sense, the Hercules Wall isn't a single event or explosion. It's a story of persistence. Its shape reflects 10 billion years of subtle cooperation, the gradual gathering of matter along invisible dark matter filaments. Over time, these cosmic rivers merged, linking galaxy clusters into bridges of light that spanned billions of light years. What began as the faintest irregularity in the cosmic background became one of the largest structures ever observed. This is gravity's art, patient, deliberate, and eternal. Unlike the explosive bursts of supernovas or the fleeting flashes of gamma rays, gravity's work is almost imperceptible, measured not in seconds or centuries but in cosmic lifetimes. And yet, it is the one constant that holds everything together, the quiet promise that the universe, despite its expansion, is still bound by connection. The Hercules-Corona Borealis Great Wall is gravity's masterpiece, a monument not to force, but to endurance, a reminder that creation does not always come from fire or fury, but from the calm persistence of time itself, working endlessly in the dark. Some scientists wonder if this colossal structure is an echo, a fossil of fluctuations in the early universe. Tiny ripples in the cosmic microwave background, magnified over billions of years, could have seeded regions dense enough to give birth to something this immense. The story of the Hercules-Corona Borealis Great Wall may have begun long before the first stars ever lit the cosmos, back when the universe was still a glowing fog of energy and light. In its infancy, everything that exists today was compressed into a dense hot plasma, a vast ocean of particles and radiation. Within that ocean, there were faint ripples, slight variations in density so small they might seem meaningless. But the universe has a way of turning whispers into symphonies. Over time, gravity magnified those ripples, transforming them into the grand structures we see today. When we look at the cosmic microwave background, we are seeing those original ripples frozen in light. A baby picture of the universe, imprinted just 380,000 years after the Big Bang. The CMB shows a nearly uniform glow with subtle mottling, regions that are slightly warmer or cooler than their surroundings. Those variations, though minute, were enough to tip the balance. The warmer regions expanded faster. The cooler ones pulled matter inward, setting the stage for the first galaxies, stars, and walls of the cosmic web. If the Hercules-Corona Borealis Great Wall is indeed connected to one of those ancient fluctuations, it would mean we are witnessing a direct consequence of the Big Bang's earliest tremors, an echo that has taken 10 billion years to reveal itself. The very same ripples that once flickered in the newborn cosmos could have grown, stretched, and evolved into this immense formation, a cosmic memory preserved in starlight. But the scale of the Great Wall is so vast that it challenges this explanation. The fluctuations seen in the cosmic microwave background are not supposed to produce structures larger than about 1 billion light-years. Hercules, at 10 times that size, seems to break the pattern. Some scientists suggest that perhaps new physics was at play in the early universe, processes beyond what our current models can describe. Maybe there were larger initial ripples than we've been able to detect. Or perhaps unknown forces, primordial magnetic fields, exotic particles, or early inflationary quirks shaped the distribution of matter in unexpected ways. If that's true, then the Hercules Wall is not just a structure, it's a message, a sign that the universe remembers more about its own birth than we do. It may hold clues to what happened in those first fractions of a second, when space itself inflated faster than light, setting the rhythm for everything that followed. When we observe it, we're not just looking at galaxies, we're listening to an ancient resonance, the faint afterglow of creation echoing across eternity. The Hercules-Corona Borealis Great Wall may be the universe's way of reminding us that the Big Bang never truly ended. Its reverberations still shape the cosmos, and us, even now. If the universe is truly uniform on large scales, then Hercules shouldn't exist. Its discovery forces scientists to reconsider one of cosmology's foundational principles: that on average, no place in the universe is special. But what if that's wrong? What if some regions are truly exceptional? For over a century, cosmology has rested on a quiet assumption that the universe, when viewed broadly enough, is smooth. This belief, known as the cosmological principle, suggests that no matter where you stand in the cosmos, the universe should look roughly the same. It's a comforting symmetry, one that places no world, no galaxy, no observer above another. But the Hercules-Corona Borealis Great Wall strains that idea to its breaking point. If this immense structure truly exists as observed, a web of galaxies spanning 10 billion light-years, then our universe is not as even or as uniform as we thought. This isn't just a curiosity, it's a philosophical fracture running straight through the heart of modern cosmology. If such enormous variations exist, the entire framework we use to describe the universe's growth might need to be rewritten. The standard model of cosmology, which relies on the idea of large-scale homogeneity, predicts limits to how big coherent structures can become. Anything beyond about 1.2 billion light-years violates those limits. Hercules is nearly 10 times larger, a cosmic contradiction floating in plain sight. Some scientists argue that we may have misunderstood the data, that the apparent wall could be an illusion created by perspective, coincidence, or gaps in our surveys. Others, however, suspect that it's revealing cracks in our understanding of cosmic evolution itself. Or perhaps space-time on these colossal scales behaves in ways our current mathematics can't describe. There's also a deeper possibility that the universe may not be perfectly uniform after all. Perhaps the early cosmos contained vast regions with slightly different densities or even slightly different physical laws. If so, then our universe may be patchy on a grand scale, a cosmic quilt stitched from regions with unique histories and properties. In that case, the Hercules wall isn't a mistake. It's a clue, a sign that we're peering into a region where the universe played by different rules. For scientists, confronting such a discovery is both thrilling and unsettling. It means that our models, elegant, powerful, and long-trusted, might only describe part of the truth. Beyond their reach lies a universe wilder and more varied than we've dared to imagine. Perhaps that's the real lesson of Hercules. Every time we think we've found the limits of understanding, the cosmos stretches those boundaries wider. The Great Wall may be less a violation of cosmic law and more an invitation, a whisper from the universe itself saying, "You haven't seen everything yet." The breaking point of cosmology is not an end. It's a beginning. The moment when science steps into the unknown, guided only by the faint light of galaxies that refuse to fit inside our theories. Our telescopes map billions of galaxies, yet what we see is only a fragment of the total. The observable universe is limited by the speed of light, a horizon we can never cross. The Hercules wall sits near that edge, taunting us with what lies beyond our cosmic reach. When astronomers speak of the observable universe, they don't mean the whole of existence. They mean the part of it that light has had time to reach us since the Big Bang, a sphere roughly 93 billion light-years wide. Beyond that, there may be more galaxies, more walls, more filaments stretching into infinity, but their light hasn't yet arrived. Space itself expands faster than that light can travel, forever keeping those regions beyond our sight. In that sense, the Hercules-Corona Borealis Great Wall is more than a structure, it's a boundary, a shimmering threshold between what we can see and what we can only imagine. Astronomers map the universe like ancient explorers once mapped the oceans, by collecting fragments of light and piecing them together into a grand design. Each dot on the map is a galaxy, each cluster a cosmic continent. Together, they reveal a three-dimensional pattern of matter and voids that grows more intricate the deeper we look. But even with our most powerful telescopes, we can only see the surface of a much vaster reality. The map is breathtaking, yes, but it's also incomplete. What lies beyond our cosmic horizon may never be known. Each second, more of the universe slips beyond our view, lost forever to the other side of the horizon. The Hercules wall rests close to that edge, a luminous frontier, marking the outer limit of the universe we can perceive. Beyond it, there could be more colossal walls, more filaments, even more vast cosmic networks repeating patterns extending without end. And yet, even within our small corner, the scale is unimaginable. Our maps contain 2 trillion galaxies, each with billions of stars. But compared to the unseen whole, that's a mere drop in a cosmic ocean. Some scientists propose that what we call the universe might be one region of a far larger multiverse, an infinite expanse where countless other universes exist, each with its own laws, constants, and histories. If that's true, then the Hercules Wall might be a ripple not just within our universe but within an endless sea of creation. Still, even partial maps have power. They remind us that knowledge is a frontier, one we're forever expanding, even as it recedes before us. Every telescope, every mission, pushes the boundary a little farther, transforming the unknown into the almost known. The Hercules-Corona Borealis Great Wall stands as both a triumph of discovery and a humbling reminder. No matter how far we see, there will always be farther still. The map of everything is not finished. It never will be. It's a living document, drawn in light and wonder, reminding us that to explore the universe is to embrace its endlessness, to keep looking outward, knowing that beyond every edge lies another horizon waiting to be found. Between these galaxies, dark filaments stretch like nerves in a cosmic brain. Gas flows along them, feeding star formation and connecting entire clusters through unseen bridges. The Hercules Wall might be the largest of these bridges, a continent in an endless ocean. The more we learn about the universe, the more we realize that it is not a collection of isolated islands, but a network, an interwoven structure where everything is connected through invisible threads of matter and gravity. These dark filaments are the highways of the cosmos, carrying rivers of gas, dust, and even galaxies themselves along routes carved out by dark matter. They are unseen by the human eye, but their effects ripple across the universe, shaping its architecture in ways we are only beginning to understand. If we could view the cosmos in its true form, not as dots of starlight but as a web of gravity, we would see these bridges everywhere. They stretch for hundreds of millions of light years, connecting galaxies into chains and superclusters. Streams of hydrogen flow along them like currents in a galactic ocean, feeding newborn stars with the raw material of creation. Where two or more filaments intersect, matter piles up, forming brilliant knots of activity. Vast clusters where thousands of galaxies gather, like glowing cities in the night. The Hercules-Corona Borealis Great Wall may be the grandest example of this phenomenon. Rather than being a single object, it could be an immense intersection, a junction where multiple dark matter filaments converge, each one carrying entire clusters along its length. These filaments act as gravitational bridges, guiding matter across billions of light years, connecting regions of the cosmos that might otherwise drift apart forever. The galaxies we see are merely the glowing tips of these hidden tendrils, bright lanterns marking the path of something much deeper and more mysterious. Recent computer simulations of the universe's evolution have revealed how these bridges form. In the beginning, slight variations in density allowed gravity to pull matter into long, thin strands. Over billions of years, those strands grew thicker as they siphoned gas from the surrounding voids. They are still growing today, slowly funneling material toward the intersections that form clusters and superclusters. The process is slow but unstoppable, a cosmic tide that has been flowing since the dawn of time. Astronomers can detect these bridges indirectly by observing how they bend light from distant galaxies, a phenomenon called gravitational lensing. The bending reveals the presence of mass, even if it's invisible. Through these delicate distortions, scientists can trace the outline of the unseen filaments, revealing the hidden framework of the cosmos. The more we map them, the clearer it becomes. The universe is a web of connections, and every galaxy is a node within it. Perhaps these invisible bridges are not just structures of matter, but metaphors for existence itself. They remind us that everything, even across unfathomable distances, is linked by unseen forces, gravity, time, and the shared history of creation. The Hercules Wall, vast and silent, stands as the ultimate symbol of that connection. A continent of galaxies bound together by bridges we cannot see, but that bind the universe, and us, all the same. If you could translate the gravitational waves and radiation of this structure into sound, it would hum at frequencies far below human hearing. A cosmic symphony, playing notes millions of years long, resonating through the silent void. The universe, though vast and silent to us, is never truly still. Every galaxy vibrates with motion, stars orbiting their centers, black holes colliding, nebulae expanding, and supernovae echoing through the dark. Together, these movements create a rhythm that fills the fabric of space-time itself. If we had the right ears, not made of flesh but of mathematics and perception, we might hear it. The deep, slow harmony of gravity and light. The Hercules-Corona Borealis Great Wall would be one of its grandest chords. Across billions of light years, each galaxy within the wall contributes its own faint tone. The radiation from ancient stars, the soft hiss of cosmic microwave background, the invisible ripples of gravitational waves, all merge into a vast orchestra of existence. Black holes merging at the centers of galaxies send tremors through space-time, producing waves so long that one oscillation could take years to complete. Clusters collide like cymbals, and the expansion of the universe provides a slow, continuous drone beneath it all. The baseline of creation. To human ears, space seems silent because the distances between particles are too vast for sound to travel. But in the language of physics, vibration is everywhere. The universe itself is made of oscillations, fields that quiver, particles that fluctuate, light that waves. Everything that exists, from the smallest atom to the largest galactic wall, is a note in an eternal composition. The Hercules Wall, with its billions of galaxies, plays a symphony, written not in melody, but in motion. If you could compress cosmic time into something we could perceive, if millions of years passed in seconds, you'd see this structure pulse and shimmer like a living being. Galaxies would orbit, merge and flare with bursts of light. The Great Wall would seem to breathe, its filaments glowing and fading in cycles that last aeons. Each act of creation, each star's birth and death, would add a note to the song. Astronomers sometimes describe the background hum of gravitational waves as the universe's music. Detectors like LIGO and future space observatories are learning to listen for it, to pick up the faint whispers of cosmic events that happened long before humans existed. These signals are more than data. They are echoes of a grand harmony, proof that the cosmos is alive with resonance. And perhaps this is why the universe feels so strange yet so familiar. Somewhere deep within us, we are tuned to its frequencies. The same laws that shape galaxies shape the atoms in our bodies. The same gravitational rhythms that move stars also move us. The Hercules-Corona Borealis Great Wall is more than structure. It is symphony. A silent harmony vibrating through space-time, unending, unbroken, and older than life itself. We cannot hear it, but it is there, a cosmic lullaby, forever playing in the dark. We are microscopic compared to the Great Wall, yet our minds can contain it. The same brain that worries about daily life can imagine structures spanning 10 billion light-years. Consciousness itself might be the universe's strangest creation, a tiny thing that can grasp infinity. It's one of the great contradictions of existence that creatures made of dust, living on a planet smaller than a cosmic grain of sand, can look out into the abyss and understand it. The Hercules-Corona Borealis Great Wall stretches across distances so vast that light itself struggles to cross them. And yet, here we are, capable of mapping it, naming it, and wondering why it exists at all. The scale is absurd, and yet the mind, somehow, keeps up. When you think about it, our entire lives unfold within impossibly small boundaries. The average human being experiences less than a century of time and travels only a few thousand miles from home. And yet, within that narrow frame, we have built instruments that can see billions of years into the past. Our neurons, tiny electrochemical sparks, have become translators of the universe. From them emerge equations that describe the birth of galaxies and ideas that stretch to the edge of space-time itself. That is the paradox of scale. We are small, yet we think in the language of the infinite. Somewhere between physics and poetry, between data and wonder, we manage to grasp a universe that should be far beyond us. The same atoms that once drifted in ancient stars have assembled into minds capable of looking back at the stars themselves. Through us, the universe becomes self-aware. When you stand beneath the night sky, you can feel this tension, the weight of smallness and the thrill of comprehension. Every star you see is part of a larger network, a pattern repeating across billions of light years. Somewhere out there, perhaps within the Hercules Wall itself, other beings might be doing the same, gazing into their own skies, feeling the same mix of awe and insignificance. We are united not by proximity, but by perspective. Science often speaks in numbers, but behind those numbers lies emotion, the quiet astonishment of knowing. We measure the distance to the Hercules Wall in light years, but what we're really measuring is our capacity to imagine. It's a feat of consciousness that the universe, in all its enormity, can fit inside a single thought, that we can hold both the infinite and the intimate, the cosmic and the human, within the same fragile awareness. Perhaps that is the purpose of scale itself, to humble us and to remind us that meaning is not lost in smallness. The Great Wall, the galaxies, the dark matter, all of it exists beyond our reach, and yet, somehow, it lives within our minds. In that way, consciousness is the universe's mirror. We are not separate from the infinite, we are its way of understanding itself. Space doesn't just contain these structures, it grows them. Matter clumps, gravity tightens, and from apparent chaos, structure emerges naturally. The Hercules Wall may not be an anomaly, but a natural expression of cosmic self-organization, the universe folding itself into form. When we think of creation, we often imagine something intentional, a design, a guiding hand, an architect. But the universe builds itself without blueprints. Its laws are simple, and yet from those few principles, infinite complexity unfolds. Gravity attracts, matter cools, energy flows. From those interactions, galaxies spiral into being, clusters form, and great filaments stretch through the dark. What begins as randomness slowly assembles into order, as if the universe were learning how to build itself from within. This process, self-organization, is written into the fabric of reality. In the smallest puddle of water, convection currents form patterns that echo the structures of galaxies. In the heart of stars, hydrogen atoms fuse into heavier elements, creating the building blocks for life. Even the human brain, another network of filaments and nodes, mirrors the same architecture that shapes the cosmos. It's as though the universe keeps repeating one idea: connection, complexity, emergence. The Hercules-Corona Borealis Great Wall might be one of the most dramatic examples of this principle. It's not a single object built all at once, but the accumulated result of billions of tiny interactions spread across billions of years. Each galaxy, each cluster, each filament formed because of local conditions, small gravitational ripples that gradually pulled matter together. Yet, when viewed on a cosmic scale, all those isolated processes merge into one breathtaking structure, coherent and alive with pattern. The universe, without intention, has composed its own architecture. What's remarkable is how this order arises from what seems like chaos. The early universe was nearly uniform, smooth, flat, and unimaginably hot, and yet, out of that simplicity came everything. The same laws that once governed a sea of plasma now govern walls of galaxies spanning 10 billion light-years. No one instructed the cosmos to do this. It simply followed its own nature, to evolve, to organize, to create structure from entropy. Even now, the universe continues to build. Galaxies collide, merge, and grow. Clusters attract new members. Filaments thicken as gas and dark matter flow through them like veins of creation. The Great Wall itself may still be growing, reshaping as the expansion of space stretches its threads across the cosmos. What we see is only a snapshot, a single frame in an infinite movie of becoming. When we gaze upon these grand structures, we're witnessing the universe's instinct for order, the same instinct that formed stars, carved mountains, and shaped the thoughts moving through your mind right now. The Hercules Wall isn't an accident nor a violation of nature's laws. It is nature. a perfect reflection of a universe that doesn't merely exist, but continually builds, refines, and creates itself endlessly. Every discovery like this pushes the boundary of what we think we know. Are we missing physics that could explain these megastructures? Could dark energy, quantum fluctuations, or higher dimensions be shaping the large-scale structure of space in ways we've yet to understand? Every so often, the universe presents us with something that doesn't fit, something that stretches the limits of human comprehension. The Hercules-Corona Borealis Great Wall is one of those things. It sits like a riddle at the horizon of knowledge, vast enough to defy our models, ancient enough to make us question how much of reality we truly understand. For all our equations and instruments, there are still regions of existence where mystery outweighs certainty. Science thrives on such edges. It's here, between what's known and what's unknowable, that our understanding evolves. When astronomers first saw the light from Hercules, they realized it wasn't just a discovery. It was a challenge. According to our theories, structures this large shouldn't have had time to form. The universe, by its current age and known physics, doesn't seem to allow for something this immense. So, if the data is correct, then perhaps the laws we trust are incomplete. Some physicists suggest that dark energy, the mysterious force driving the expansion of the universe, might behave differently than we think. Maybe it interacts with matter in subtle, unrecognized ways, allowing regions of space to grow denser and larger before the cosmic expansion pulls them apart. Others propose the influence of quantum fluctuations, tiny ripples at the dawn of time that may have stretched across vast distances during cosmic inflation, seeding megastructures far bigger than we ever expected. There are even ideas that the universe we see is not the whole story. If higher dimensions exist, curled up or hidden beyond our perception, they might subtly influence how gravity behaves on colossal scales. Perhaps the Great Wall is not merely a structure of galaxies but a shadow of a deeper geometry. A clue that the true architecture of reality is far stranger than we can yet imagine. Yet despite all these theories, there's humility in admitting how little we know. Every time we push deeper into the cosmos, we find that the universe refuses to fit neatly into our models. It stretches, bends, and unfolds in ways that remind us that science is not a monument of facts, but a living process, an ongoing conversation with the unknown. The Hercules-Corona Borealis Great Wall reminds us of that conversation's vastness. It whispers that the cosmos may always remain partly beyond our grasp, that knowledge has no final edge, only horizons that shift as we approach them. Maybe that's the beauty of it, that even in a universe governed by laws, mystery still finds a place to hide. And perhaps that's what keeps us reaching outward, not the certainty of answers, but the quiet thrill of knowing there is still more to learn, and always will be. If you could fly at light speed toward the Hercules Wall, you would never reach it in your lifetime. Not because it's too far, but because the space between you and it is expanding faster than you can move. The destination recedes forever, like a horizon you can never touch. This is one of the most humbling truths about our universe. Movement itself has limits, not just because of speed, but because of the nature of space. The cosmos is not static. It stretches, constantly, everywhere, all at once. Galaxies don't drift through space like boats on an ocean. They are carried by the expansion of space itself. And the farther away something is, the faster that expansion pulls it from us. At great enough distances, even light cannot close the gap. So if you pointed your ship toward the Hercules-Corona Borealis Great Wall, you could travel at the speed of light, the ultimate limit, and still, the wall would retreat faster than you could ever chase it. The photons you send ahead, carrying your message or your gaze, would never arrive. The wall exists in a part of the universe that's not just far away, but moving away in a way that defies pursuit. It's like trying to reach the edge of a mirage. No matter how far you travel, the horizon keeps expanding before you. If you could somehow pause the cosmic expansion and make the journey, it would take 10 billion years to arrive. 10 billion years, the lifetime of stars, the slow evolution of galaxies, the birth and death of countless worlds. By the time you reached it, the universe itself would have transformed beyond recognition. Stars would fade, galaxies would shift, and the light from your point of origin, the Milky Way, might no longer exist in any visible form. But even though we cannot reach it, the Hercules Wall is not beyond our understanding. We touch it in a different way, through light, through mathematics, through imagination. When telescopes capture its ancient glow, we are already connected to it, not by travel, but by time. We see what it once was, not what it is now. We experience it as a relic, a fossil of the universe's youth. And in that sense, the distance between us becomes less about miles and more about memory. To think about unreachable places like this is to feel both awe and sorrow. There are parts of the cosmos we will never see, never touch, never explore, not because we lack the technology, but because the laws of reality forbid it. The universe hides parts of itself behind horizons that grow faster than our curiosity can chase. And yet, the act of imagining the journey, of picturing that unreachable place, bridges the gap in another way. If you could travel there, you would see galaxies stretched thin by distance, their light warped by time, all shimmering in silence across the black. You would see the universe as it was when it was young, and realize that, in a sense, you've already been there, because to imagine the unreachable is the closest thing to touching infinity. For all its grandeur, the Hercules-Corona Borealis Great Wall is utterly silent. Stars burn, galaxies collide, but across its length, the vacuum reigns. Silence, in this context, is not emptiness. It's the sound of eternity at rest. Silence in space is not the absence of motion or energy, it is the absence of air. Sound cannot travel through the cosmic void because there are no particles to carry its waves. The universe, for all its beauty, is a quiet place. Even the most violent events, a supernova erupting, a black hole consuming a star, two galaxies merging in a cataclysm of light, occur in perfect stillness. If you could stand within the Hercules Wall and witness such wonders, you would hear nothing. Not a roar, not a whisper, only the steady hum of your own existence. It's a strange paradox. The most dynamic, luminous processes in nature unfold in absolute silence. Every second, within the Hercules-Corona Borealis Great Wall, billions of stars are born and die. Entire galaxies are colliding, scattering dust and light like sparks from a forge. Yet if you could drift among them, your ears would register only quiet, an endless, tranquil void stretching in all directions. The cosmos conducts its symphony, not in sound but in light, gravity, and time. That silence, though, isn't lifeless. It's full of meaning, full of history. The emptiness between galaxies carries the imprints of everything that ever was. Photons from ancient stars stream through it, cosmic rays dance invisibly through its depths, and gravitational waves ripple softly, bending the fabric of space itself. The silence is not a void, it's a canvas upon which the universe paints. And within that canvas, the Hercules Wall looms like a frozen chord in the cosmic symphony. Its vast filaments glow faintly, their galaxies whispering in frequencies of light rather than sound. If we could translate those waves into something audible, the structure might hum in a deep, cosmic note, one so low that it would take millions of years to complete a single vibration. The silence of space hides a rhythm too slow for human senses to perceive. It's easy to mistake silence for nothingness, but the universe reminds us otherwise. The quiet between galaxies is not void, it's balance. It's the pause between cosmic heartbeats, the stillness that gives meaning to motion. Every act of creation, every flash of starlight, every collapse of a dying sun depends on the calm that surrounds it. Without the quiet of space, there would be no room for light to travel, no stage for gravity to perform its endless dance. In that way, the silence of the Hercules-Corona Borealis Great Wall is not absence. It is presence, the ultimate expression of peace on a cosmic scale. It reminds us that even in the most magnificent structures, even amid endless energy and light, there is a stillness deeper than time itself. If you listen closely, not with your ears but with your mind, you can almost hear it, the quiet murmur of eternity resting in the spaces between the stars. If one wall exists, could others lie beyond our observable horizon? Structures we'll never see, repeating like echoes across infinity. The universe might be filled with walls upon walls, a fractal pattern without end, each a reflection of the same cosmic rhythm. Our view of the cosmos is bounded by light. We can only see as far as light has had time to travel since the dawn of creation, about 13.8 billion years. Beyond that lies a curtain we cannot lift, a horizon we cannot cross. But that boundary does not mean the universe ends there. It simply marks the edge of our knowing. The Hercules-Corona Borealis Great Wall may be just one visible part of a far larger structure, a single verse in a poem that continues beyond the reach of our telescopes. When astronomers map the universe, they find patterns that repeat. Filaments form, then cluster into walls, and those walls in turn seem to gather into even larger arrangements. The cosmic web reveals itself as fractal, similar shapes repeating at different scales, from clusters of galaxies to the great structures that span billions of light years. If the pattern continues beyond what we can observe, then there may be countless other great walls out there, stitched together into a cosmic architecture too vast for light to describe. Perhaps the universe mirrors itself endlessly, a reflection stretching beyond time, where every wall has its twin, every filament its echo. In such a universe, the Hercules wall would not be unique, but part of an infinite design, like one note in an endless melody. It's an idea both beautiful and terrifying, that we are surrounded by infinity, and yet can only ever see a small circle of its reflection. Some cosmologists speculate that our observable universe may be one bubble within a far larger multiverse, an infinite sea of universes, each with its own version of space, time, and physics. In that view, our universe is not the only mirror, but one of many, a single bubble in a foam of endless creation. If that's true, then the structures we call impossible may simply be the natural expression of a reality that repeats itself on every level, from the quantum to the cosmic. And yet, even without invoking other universes, the idea of repetition is everywhere. Nature favors symmetry. The spiral of galaxies mirrors the spiral of shells. The branching of filaments mirrors the branching of trees and rivers. The same laws that shape the Great Wall shape our DNA. Perhaps the universe reflects itself not just in space, but in form and function, a single principle, echoing endlessly across scales. If there are other great walls beyond our horizon, we may never see them. Their light will never reach us, forever redshifted by expansion into invisibility. But imagination allows us to glimpse what our eyes cannot. A cosmos without boundaries, filled with reflections of itself, infinite and self-similar. In the end, perhaps the mirror universe isn't out there at all. Perhaps it's here, within us. In the way our minds can imagine infinity. In the way the cosmos repeats its patterns in everything it creates. The Hercules-Corona Borealis Great Wall might not just be a structure in space, but a reflection of a deeper truth. That the universe, like a mirror, is always looking back. The Milky Way is just one faint spark in a local filament, a single thread woven into this unimaginable network. To think that somewhere within this grand tapestry, you exist, breathing, thinking, wondering, is both humbling and miraculous. Our galaxy is part of a vast supercluster known as Laniakea, a name meaning immeasurable heaven. Within it, hundreds of thousands of galaxies flow along invisible filaments, drawn together by the quiet pull of gravity. If you could zoom out far enough, you'd see that Laniakea itself is only one cell in the immense cosmic web, a faint vein in a structure that stretches across the observable universe. And yet, within that single thread lies everything we have ever known. Every sunrise, every thought, every song, every moment of history, all suspended in a vast ocean of stars. It's easy to forget that scale does not define significance. We are small, yes, smaller than small, but we are not irrelevant. The atoms that make up your body were forged in ancient stars scattered across this very web. The iron in your blood, the calcium in your bones, the oxygen in your lungs, all of it once drifted through the same cosmic filaments that bind galaxies together. The universe built you from its own dust, and through you, it now contemplates itself. If you could trace our cosmic address, it would read like poetry. Earth, solar system, Milky Way, local group, Virgo supercluster, Laniakea, a filament of the great cosmic web. Beyond that, the line fades into silence, swallowed by the unreachable regions of the universe. And still, within that fragile filament, consciousness has bloomed. The ability to wonder where we fit within all this, to see the pattern and recognize our place inside it. When astronomers map the web of galaxies, they often color-code the filaments, revealing luminous strands connected in intricate patterns. To the human eye, the result looks uncannily like neurons in a brain. The connections between galaxies mirror the connections between thoughts. Perhaps that's more than coincidence. Maybe the universe is not just a stage for consciousness. Maybe it behaves like one itself. The same principles that link stars and galaxies might also govern the structure of our minds, the way ideas connect and awareness emerges. From that perspective, our smallness becomes something sacred. The Milky Way may be a mere whisper within the Great Wall, but that whisper carries meaning. To look up and comprehend the cosmos, even partially, is to participate in its unfolding. We are not separate from the web. We are part of its living fabric, woven from the same threads that stretch across the stars. So when you stare into the night sky, remember, you are not looking at the universe. You are looking from within it. Every photon that reaches your eyes has traveled through the same grand structure that cradles our world. You are both observer and participant, a node in the cosmic network, aware of itself for a fleeting, miraculous moment in time. To gaze upon Hercules is to remember that the universe is not built for us, yet somehow allows us to exist. These colossal walls, these structures of galaxies and light, are reminders that beauty and mystery are not opposites. They are the same thing seen from different scales. Standing beneath the stars, it's easy to forget just how vast the cosmos truly is. The Hercules-Corona Borealis Great Wall spans 10 billion light-years, a structure so immense that even our most powerful telescopes can only glimpse fragments of it. To us, it is almost beyond imagination, and yet, the same physical laws that bind that structure together also shape the air in your lungs, the orbit of our moon, the beating of your heart. The universe does not make distinctions between the grand and the small. It follows the same rhythm everywhere. When you adopt the cosmic perspective, the boundaries between the human and the infinite begin to blur. We often imagine the universe as something out there, distant and separate. But it isn't. It's here, within us, around us, flowing through every atom that makes up who we are. The carbon in our cells was born in the cores of ancient stars. The oxygen we breathe was released in supernova explosions that lit the first galaxies. To gaze upon Hercules is to look at our own ancestry written across the night sky. This perspective doesn't diminish us. It deepens us. To know we are small is not to feel insignificant. It is to understand that smallness can still hold wonder. Every human being who has ever lived has existed within one tiny corner of a single galaxy. Yet within that narrow space, we've built civilizations, written poetry, discovered laws of nature, and reached out to touch other worlds. We may never travel to the Great Wall, but the fact that we can comprehend it, that we can measure it, describe it, and feel awe in its presence is its own kind of miracle. Carl Sagan once called this view the cosmic perspective, an awareness that humbles pride, sharpens compassion, and expands imagination. It reminds us that our struggles, our joys, and our stories unfold within a universe far larger and older than we can grasp, yet one that includes us completely. The same fabric that holds galaxies also holds you. The same gravity that binds Hercules binds your feet to the earth. You are not an observer of the cosmos. You are one of its expressions. When you realize this, something changes. The universe stops being a distant, cold expanse and becomes something intimate, a vast living whole of which you are a conscious part. The Great Wall, the filaments of galaxies, the tiny planet you call home, all are threads of the same tapestry. To see the universe this way is to understand that we belong not because we are central, but because we are connected. The cosmic perspective is not about our place at the top of creation, it's about our participation in it. And when you look at Hercules, glowing faintly across billions of years, it's as if the universe itself whispers back, "You were always meant to notice." Maybe the real mystery isn't how such a structure exists, but why we can perceive it at all. Why the universe gave rise to eyes, minds, and curiosity, tiny pockets of awareness capable of dreaming about 10 billion light-year walls of galaxies. Out of all the countless possibilities in the cosmic story, somehow the universe produced something that could wonder. Stars ignited, galaxies formed, planets cooled, and eventually, one small world developed creatures capable not just of survival, but of reflection. Beings who look up at the night sky and ask questions that reach beyond their own lifetimes. This capacity to ask why may be the most extraordinary phenomenon of all. When we think about structures like the Hercules-Corona Borealis Great Wall, it's tempting to focus on the mechanics, the physics, the matter, the equations. But beneath all that lies a quieter question. How is it that the universe became aware of itself? How did a vast expanse of energy and dust develop the ability to look back, to think, to know that it exists? Consciousness may be the universe's most subtle creation, not a physical structure, but an emergent property of complexity itself, arising from the same forces that shape galaxies and stars. Perhaps the reason we can perceive something as grand as Hercules is that the universe has always been moving toward awareness, toward the ability to see and reflect. Just as gravity gathers matter into clusters and walls, perhaps evolution gathers perception into consciousness, pulling scattered neurons into networks of thought. In this way, the act of observing the cosmos is not separate from its creation, it's a continuation of it. The universe didn't just build galaxies, it built beings who could feel wonder at them. And yet, for every answer we uncover, new questions unfold. What is consciousness, really? Why should a collection of atoms, governed by the same physical laws that govern stars, develop imagination, empathy, and awe? Why should matter care that it exists? These questions sit at the edge of science, where knowledge dissolves into mystery. Perhaps they will never be answered completely. Perhaps they are not meant to be. Still, we keep asking. Because curiosity is its own kind of gravity, it pulls us forward, binding generations together across time, each one reaching a little further into the unknown. The same curiosity that once drew early humans to look up at the stars now drives astronomers to map the edges of the universe. It's the same force, expressed in different forms, guiding us toward a deeper understanding of where we belong. Maybe that's the universe's quiet intention, not just to exist, but to be seen, to create eyes to admire it, minds to contemplate it, and hearts to feel its beauty. In that sense, every question we ask, every why and how whispered into the night, is an act of cosmic participation. The universe gave rise to us, and through our wonder, it continues to know itself. The question that never ends is not a flaw in understanding. It's the pulse of existence itself, the endless curiosity of a universe still unfolding, still becoming, through the only way it knows how, by asking. And so, we come to the end of our journey, drifting back from the edges of creation, from the luminous threads and distant walls that stretch across the universe. We've traveled through billions of years, across galaxies and gravity, through silence and time itself. And yet, somehow, we return here, to this single moment, this small blue world, this breath. The Hercules-Corona Borealis Great Wall stands as a monument to the scale of existence, a structure so vast that it humbles every thought we have about size, distance, and possibility. But in that humility, there's peace. Because to know we are small is not to feel lost, it is to understand that we belong. We are not separate from the cosmos, we are made of it. The same atoms that shine in distant galaxies move through our veins. The same gravity that binds the stars holds our feet to the earth. Every photon we followed tonight began its journey long before we existed. And yet, somehow, those ancient lights found us, to remind us that the universe, in all its immensity, is aware of itself through us. You are part of its memory, part of its unfolding story, part of the pattern that connects every star, every wall, every spark of consciousness. So, as you rest now, let your mind drift among the galaxies. Let the noise of the day fade away. Feel the quiet weight of the cosmos settle around you, vast, timeless, and kind. You are a moment in infinity, and infinity, for this brief heartbeat of time, is alive within you. Sleep well, traveller of stars. The universe will keep turning, and when you wake, it will still be waiting, infinite, mysterious, and beautiful beyond measure.